Hi. A couple of weeks ago, people left some comments saying that they would really like to know how Rye works internally and why it works in the way it does. And I figured this might actually be a good idea to walk you through some of the elements of how it works. Because even if you don't want to contribute to Rye, maybe you have some interest in building something similar for a different environment, and then it's quite interesting to learn how this functions. I want to walk you through two parts: how the shims work, and more or less sort of how the basic architectural decisions in Rye are, which involves the installation also, and basically how it gets a Python interpreter in place. So if you're not familiar with Rye, you can go to ryeop.com and download it. If you have Python or if you don't have Python, Rye will always give you Python. So if you have Rye here, it can fetch tool chains. And a tool chain is basically a Python distribution. We can see which ones are installed. Tool chain list. So this, on my machine, Rye has provisioned these different versions of Python. I don't actually know why I have so many 3.11 ones, but I do know that we use some for Sentry, and I use Rye there as well. And so basically, when you run Python, it will give you a Python version from somewhere in here. And I will demonstrate this to you in a temporary folder in temp. So I'm going to create a new Rye project here, Rye init. And if I do Rye sync, it will basically make a virtual env here, right? This is a standard virtual env on different versions of different platforms that look a little bit different. This is what it looks like on macOS, and Linux will look almost the same. On Windows will be a little different. But what is special is if I, let's add a dependency, let's just add Flask here. I can import Flask. Okay, I can also import this my project here, which happens to have a hello function, because this is what it generates by default. So this is what it sets up out of the box. But if I run Python, for some reason it picks up this Python in this virtual env, and you can see this because if I do sys prefix, you can tell that this is the Python from in here. So how does running Python here give me the Python from in here, right? Because there is in fact a Python here I can run. And what happens is that it will actually always give you this shim Python. And this in itself will do the right thing to locate the Python of the virtual env that you're working with. So despite the fact that Python in itself doesn't really understand anything about virtual envs, this Python can. And in fact, this can also do something else. If I run Python here, it just picks up the default Python. I also have this set up so that if I run 3.11, it will find a suitable Python 3.11 and run this instead. This is very similar to how cargo in Rust works. And now I want to show you how this works, because this is probably the first element of understanding Rye. What's important to understand is that the only thing that you need on your system for Rye to function is you have to have Rye installed. And at the end of the installation, it will put something in your profile where it will source this environment file. And if we look at what this environment file does, it just adds shims on the path. That's really all it does. So if it's not on the path yet, it will add it. Okay, so what is this Python shim, right? What is this Python shim that it finds? Well, it is just an alias for Rye. On first installation, it will set this up. So let's see where the installation actually happens. And for this, it's quite important to understand that there are two ways to install it, but they're actually the same. On Windows, you just download this executable. On other platforms, you can either download those or you can run this script. Let's look at what this script does. It, in fact, just goes and downloads the latest version, and then at the end, it just runs it. which is, so it will make the file that it downloads executable, and then it will run self-install. That's all it does. So let's go to the installation part in Rye. This is install, and it goes through a bunch of stuff that's not so important, but basically, this is the wrong one. Sorry, self is called Rye here for reasons. It will, it has two ways in which you can do it, either a cargo-based installation or like a regular-based installation. This is the update. Let me see where the install is. It runs perform install, and at some point in here, it will execute. Where is it? Ensure self VNF with toolchain. And this will effectively install everything into .rye. So you end up with bootstrapping a bunch of different things. The first thing it bootstraps is UV. So this is what creates this UV folder here. And this is because Rye already uses UV in all cases to install its internal tooling. Even if you want to use pip tools, which is still the default, it will bootstrap through Rye. And then it will install a Python. So it will install one of the Pythons in here. Typically, we'll install a Python 3.12, which it does through ensure specific self toolchain, ensure latest self toolchain. This will basically download the Python from the internet. And then at the very end, it will create this Shims, update core Shims. And so depending on the operating system, it will, so the goal is to create this Python shim here, but depending on the operating system, it will do a different thing. So on Linux, it will make a hard link from this, which is, so it will have installed Rye first into Shims. So you end up with a Rye here, and it will symlink this one to, well, on Linux, it will hard link it to Python and Python 3. On macOS, it will symlink it instead. And on Windows, it will also make a symlink if that Windows version supports symlinks, and it will fall back to hard link otherwise. And so it does this on every update and does it on every installation. So you basically end up with Rye here through the regular installation, and then you will also end up with Python here. And you can see that Python and Python 3, they just symlink to Rye. So somehow, if I run Python, it doesn't run Rye, right? That's what happens. So how does this work? Basically, in main RS, it executes the CLI. This is where all the code runs. And after some common initialization and parsing the arguments, it starts executing. It starts to try to execute the shim. So this is where this happens. And the first thing it does, it takes these arguments. So this will be Rye version, for instance, would be the argument, or Python version would be the argument, right? So if it will see argument 0 will be Python, and then dash version will be the second argument. It will go to detect shims, and it will try to see if we are in fact supposed to execute a shim. Under normal circumstances, this should never happen, but it can happen in some weird cases. The first thing it does, it tries to figure out what are we called. So as it disregards the first argument, even though that this also would be Python, it just checks where are we. So it asks the operating system what is running. And this will, if I run Python, this will tell me we are in Rye Shims Python. This is what it will tell me. And this is, by the way, why we have to do hard links on certain operating systems and can do symlinks on others. So on macOS and on Windows, a symlink will be fine. On Linux, if you were to do a symlink here and you run this here, it will show up as Rye because it always resolves the symlink before running. So if we end up in with the shim name, which is the file name part of it versus the last part, if we end up here and it's called Rye, then we don't do anything. It's not a shim because we're literally running Rye, right? That's what this does. But otherwise, if the parent file name, so this is the folder which is contained and is called Shims, is not called Shims, then we go out. But otherwise we say like, well, now we're trying to run this shim. And we can demonstrate this also by making a folder here. Let's call this shim test. And I symlink Rye shims Rye here and call it Python. LNS. Sorry, I did it the other way around. I think I did it wrong. LNS Rye shims Rye Python. Okay. I don't know what I did wrong. If I run Python here, we'll actually run Rye. And the reason is that even though the shim name here would be Python, the parent folder is not called Shims. So if I make a folder called Shims here, and I move Python into Shims, and I run Shims Python, we can see that it detected that it needs to run Python, right? So this is where this is coming in. And so we will enter this code path where we found the shim. The next thing it does, it will discover this Py project. And so what I want to do here is I want to show you that we are in fact, I will just try to print this here to show a little bit what's going on. So what we're going to do here, we're going to recompile Rye, and I'm going to install the development version. So when I run the shim here now, we can see that I didn't find the Py project, right? Because in fact in shim test there is no Py project. If I were, however, to go into my X here, I can already see that my shell also did some stuff. If I run Python here, we can see now that it prints out a lot of stuff because it did find my Py project. So I'm going to turn this off for now because it's kind of annoying. Why does it do that? Well, because it wants to find the right Python version. And the Python version can depend on which project I'm in. So the first thing after we have figured out that we need to run a shim here is we first try to figure out what's the target of the shim. Rye supports 3 shims. Pip, which is actually a shim that's not really supposed to be used, and then the different Python version. Python, Python 3, Python W. And then it will spawn this shim. There's also like an error path for certain uses which we're just going to ignore. So next thing is we want to spawn, sorry, this is not what I want to show you. I first want to show the Shim Target. So basically when we have a Py project, which is what would happen here, right? There's a Py project. Then we want to customize the shim's behavior based on if Rye manages this project or if anything else does it. And basically what happens is that first it will check if the thing that we are running is a Python shim. And this is pretty straightforward. If it's called Python or Python 3, then it's a Python shim. In that case, if you also try to use this special syntax called +3.11, it will tell you this error. Explicit Python selection is not possible within Rye managed projects. If I were to do this outside, I can do this to get a specific version of Python, right? But in a Py project, we don't want to support this because it's a little bit nonsensical. Instead, what we're going to do now is we're going to take the arguments, we're going to look for the virtual env of that project, and we're going to look for our target in that folder. So basically, if I run Python here, it will look for the Py project's virtual env. So I can do foo here, right? Even in the subfolder, it will still find it. Why? Because it locates the Py project, which is one folder up, just here. Then it looks for venv path, which is this here. And then it joins the bin path, and this is actually different on Windows and Unixes. On Unix it's always venv bin. On Windows it would be venv scripts, right? And then it says, please find me the target, which would be Python 3 in that folder. If it finds it, it replaces the first argument with the path to this, and then it says, please continue execution. So if we look for this, these are the new arguments, and then it says spawn shim. Otherwise, there's a special case for Windows where the setup is a little bit different, so we also need to look for Python if Python 3 is detected. We have a special code in here for pip. I guess the pip shim is a little bit different. But otherwise we're done within a project. Globally, we also allow shims to select a specific Python version that we ever mentioned before. And it does a little bit of extra logic here, but basically does the same thing. At the end, we spawn the shim. So I can show you this here. We basically say like, please make me a new command, which is to this target. I will add this here so you can see what it runs. So if I reinstall this, and then here I run Python, you can see that it tried to now run venv bin Python. And if I run python-version, you can see it tried to run this with version. I'll turn this off again because it also messes up my shell prompt. Okay. So now it needs to execute this, and this is a little bit annoying because here we need to do a bunch of extra things that seem to be unnecessary but really aren't. On Unix, we replace the process by calling exec. So basically, Rye will cease to exist, and instead we are replacing this program with Python entirely. This is also why this function doesn't really return ever. On Windows, we run it normally, but we do then call exit with the status code of the inner program. So on I can show you this like this. If I run os get pit, right? This is my pit, and then I run activity monitor, and we're going to look for our process here. This unfortunately is a pretty suboptimal way this works. So somewhere here there's process 15402, right? This is our Python here. And if I now change this display to hierarchical, wherever this is, I lost track of it. That's annoying. Let's see if I can find it by name. Let's see, Python. Alright, so you can see here, this is our Python, and the parent process is my shell, my login shell, and then it goes to TTY. On Windows, there would be an extra layer in between. There would be a Rye outside and a Python inside, because you can't really replace the process on Windows without messing up a bunch of other stuff. There's a second thing though it does, which is it disables the Ctrl-C handler. And it says it's technically only necessary on Windows. It's on other platforms is not so important because it will only affect this very brief period of time between here and here, which doesn't really do anything. The reason we disable the Ctrl-C handler is because we don't want to have the outer program kill the inner one. We want to have the Ctrl-C handler being picked up by the inner Python only, and when it wants to shut down, it will do so. Basically what this does is on Windows, if I press Ctrl-C, if I were to not disable my outer handler, it would kill Rye, which would then kill the subprocess. So we don't want to do this. And the way this is implemented is basically just it sets a global variable to true, and I have a global handler that always runs in a separate thread. So if it gets the Ctrl-C command, this will run. If it has please disable this, it will clean up a bunch of stuff and just exit the process. But if it's disabled, it will not do that. And that is the basics of how these shims work, right? Very, very straightforward. It basically only requires this shims path to be on the load path. And then it will work. So you don't have to have any weird shell integrations or anything like this. The second thing I want to show you is basically how Rye gets Python installations, because this is also untypical. There's one extra thing I should show you, which is what happens if you're outside of a project that is Rye managed. In Rye, there's a config file, and depending on how you go through the installation wizard, this global Python is either set to true or false. So let's go here. This is clearly not a Py project. This is just some random folder. If I run Python here, it will give me Python 3.12 because this is the default Python, the default tool chain, and global Python is set to true. If I set this to false here, and if I were to run Python, you actually get this weird error. This is right now because there's actually a Python file here. So let's run this again. Now I get Python 2.7. How is this possible? What's going on here? Well, actually, it's still Rye, but now Rye will not provide this global Python. Let's turn this on again. Now we get a Rye Python again. What's going on here? Well, it's still this shim code. So basically, in the global path, so we're outside of a Py project. So now we're in this path here. If we are Python shim, which is the case, we load the config and we skip over this part, which is not very interesting. And now we check if global Python is enabled, this one. If it is enabled, then we're going to try to locate one of our own Pythons and say like that's the version we want, or the default one. If it's disabled, then we will actually try to find a different Python. And so when this is false, right, we enter this code path. Find shadow target is what's going to run here. So what's going on here? Well, it will find the current exa, which is the Rye thing, and it says like find along all of path, right? It will take every one of those entries, and it will check, does a Python exist? And so we can actually do this. We can print this. Let's turn this off. Let's run Python for a second. So we can see first it tried to find this here, right? Which would be ourselves. So is same file would return true. So we don't want to run this. So we continue. The next one would be pyenv. This is in fact what it will find. So I will just remove this again so it doesn't annoy me in the future. It will have now found pyenv, which is also what I've installed, and it seems like pyenv gives me Python 2.7. And then it will spawn this. There's an extra level of complication on Windows, because on Windows you can get this Windows Store installer, and so we want to skip over this one. So we'll always continue. And this allows me to have Rye be non-invasive, I would say, if you don't want Rye to provide global Pythons. But now I have this turned on again. Sorry, I need to edit. Right, so I want to turn this on again. And so now we're back to where we were. And so the last part I want to show you is how Rye actually gets to its Python versions. Let's say let's ask Rye what's installed. Well, these ones are installed. It can, however, fetch me more, and I can ask to fetch a specific version. I can also say downloadable. It can also tell me which versions of Python are even remotely installable on this machine, right? So I could ask for any one of those. So let's say I want this version of Python. I can now do Rye toolchain fetch this version, and it will download this. It will give me this now, and I can do Python this, and now I'm actually running 3.8 emulated on Intel, even though this is an M1 Mac. And if I do Rye toolchain list, you can see that it has installed this one. So where is it getting these Pythons from? It clearly didn't compile anything. And the answer to this riddle is actually a very amazing project, which is called Python build standalone. So this repository run by Gregory, he basically started building redistributable Python versions for Mac, Linux, and Windows. They're not perfect, they have some challenges, but they are redistributable at a random location. So I can download these, and this will allow me to make any of these Python versions available to a user of Rye. So there are a lot of these releases. So this one, for instance, is the latest release that has a bunch of Python 10, 3.10, and if you actually look at how many there are, it's a ludicrous amount, right? A lot of these Python builds. And so Rye will basically download these. How does it get them though? It gets them by having a massive file called, it's in here, sources generated. There's a python downloads.inc file, which is a full list of every flavor of Python and the download URL and the checksum. So when you run Rye fetch, it will actually go there. Because there is no real API to get them, there's some pretty unwieldy Python code somewhere called devtools find downloads, which runs nightly on a pull request, and it will basically go through the release list with the GitHub API, and it will try to sort these random file names that it finds here, right? It will try to parse these file names and map them into this mapping. And so when the fetch code is run, which is here, it will call this fetch function, which given a version request, which is basically if I say Python plus 3.11. 3.11 is parsed into version request. And then it will try to resolve it into full version, which is, it will basically take 3.11 and turn it into CPython at 3.11.8, which is the latest one that it has available. And then it will go and get this download URL, where basically it iterates through all these Python versions and it checks if it's a matching version, and then it returns the resolved version plus the download URL, and then it will attempt to just create a folder for it, which will be here, right? It creates this folder, and then it just downloads the URL, it unpacks it, it checks the checksum before it does that, so then it unpacks it, and at the end you end up with a fully functioning Python installation in here, right? So this is in fact a Python installation. And everything is in here. Now, there are some challenges with this distributions. The most notable one is that these are what I would call non-GPL builds of Python. So a Python here doesn't contain any GPL code, which is great for redistribution, but it has the downside that readline doesn't work. So when you try to insert characters which are not Unicode on a UTF-8 terminal, there's some stuff is messed up. That is unfortunate because readline is GPL, and so it cannot really be redistributed without making your entire app also GPL. So the original purpose of these Python installations was to enable self-contained Python installations, so like py2exe, and so they don't contain any GPL code. The second problem with those installations are that Python itself doesn't really support redistributions all that well, so there can be problems with compiling, because the files that are contained in here side packages. There's a sys config file, right? Sys, sorry. Where are we? Side, not side packages. It's here. Sys config Darwin. These folders, these file locations here, they are like from the build machine, right? This folder totally does not exist, as an example, this temporary folder. Or a classic problem is CC is hard-coded to Clang, like all this sort of stuff. So there can be challenges with actually compiling C extensions. And it would be great to solve this, but it's a lot of work to make some advancements in this area. And Python itself, when you download it on python.org, it only ever runs if it's installed to one very specific location. So you couldn't place it at this path here. And it would be great if you could actually download these Python versions directly on python.org for all the platforms, but unfortunately that doesn't really quite work, at least not the way it's built today. There were some proposals by people in the community to build a PEP to make these builds somewhat official, to have python.org build these builds. But for now, it's great to have this community project that gets us going, because it's a lot more fun if you can just go to a random project and start using the right Python version than if you manually have to do this. Yeah, so that is the basics of how Rye works. It basically, whenever it is in a folder where there's a Python project going on, right, this Py project file, it will automatically detect this as, because there's a tool Rye manage equals true flag in here, as being the base of your operation, and you don't have to activate or deactivate virtual envs anymore. And I think that's the basics for what I want to show this time around. Maybe we'll go some deep diving into how some of the rest works. The only last thing that I wanted to mention about this type of thing is that, first of all, if you have a specific interest on what I should cover next time, maybe leave some comments. But also that it was probably already pretty clear from this presentation that some of the things that Rye does is a little bit like going outside of the of what Python normally wants you to do, right? There's a whole bunch of stuff that it has to do, from redistributable Python versions to like this Shim kind of stuff. It's really just an added layer on top of regular Python. And so there's a hypothetical future world where Rye might not have to do any of this, right? But today this is a pretty straightforward way in which it can operate. And Rye was not the first one to come up with this. In fact, I use Volta, which is sort of a similar kind of thing. In this case, actually now it's my Sentry setup messed this up, but I have a Volta installation here, which does the same thing, right? All of those executables here from the node world, they are also these Volta shims, right? So I learned a bunch of this stuff from here. Volta does more that I don't quite like, but we'll also do these global installations in here. But for the most part, this design came from other systems. Cargo does something very similar. If you use Rust, all these things here, they are Rust C. That's a hard link to Cargo itself, to Rust up itself. And so many of these ideas didn't come from Rye. The fact that you can do Cargo plus stable, right? I took this entire idea with this 3.11. So a lot of these ideas, they came from other environments. So even if Python over time might learn some of the features that Rye has, there's still quite a bit of benefit of the general approach, and you might find this useful for other tooling as well. So anyways, that's it for today. Let me know if this is useful, if you want to see more of this or less. And yeah, see you around.